Alrighty, here are the notes for 1.14 and 1.15, defining rotations. Okay, so if I'm going to turn a line segment into triangles, your book started off with a line segment that looked like this, right? And it said A and B. Okay, and then they asked you to rotate it 90 degrees counterclockwise around A. So A is right here, right? So if I twirl it so that 90 degrees, then that means the line's going to be up there, right? So if I twirl it 90 degrees, the line now is up here, if I'm turning it counterclockwise. So by turning it that way, and then connecting the endpoint to B to the new endpoint, I'm going to end up with a 90-degree angle, and it's going to be isosceles. What does isosceles mean? It means that two sides are the same length. That is the definition of isosceles. And so we've got two sides the same length, which makes it isosceles, and a right triangle. Okay, and AB is the same length because we did a rotation transformation. Okay, so if you need to look at this some more, you should hit pause and then write some more. Okay, next one. Okay, so let's talk about this. They gave you a picture like this, and it says rotate it 30 degrees and draw CD prime. That's this green line. Then you're going to rotate it again 30 degrees and get C double prime. That's the blue line. So if I rotate it 30 degrees and then another 30 degrees, we're going to end up with a total of 60 degrees. Okay, so what kind of triangle did we end up drawing? If I connect D double prime to D, we end up with an equilateral triangle. These sides are all the same. What other properties do we see? We can see that the green line here is an angle bisector for D double prime C D. Now we always put the letter that's in the point that's in the middle of the angle is always going to be the center point of our angle. Okay, all three sides are the same length. All three angles are 60 degrees. Okay, let's look at this next one. I'm going to zoom up a little bit. Okay, so there's an equilateral triangle inscribed in the circle. Okay, what is the smallest angle you can rotate it around point D so that A becomes an image of B? So basically, I want to twirl this around so that A is on the same location as B. So if I twirl my notebook so that A is now at the top, how many degrees have I twirled it? So I've twirled it this amount, and that amount is 120 degrees. And we did that type of twirling back here when I twirled it that amount and I twirled it 120 degrees. This is a really good example of twirling 120 degrees. Okay, next. And please feel free to hit pause or rewind and watch it over again. So here are some different shapes. Section 15 is all about lines of symmetry. A line image that passes through the center of an object and divides it into two equal parts. So all of these lines here, if I folded it or reflected it on that line, it would end up looking just the same. So if I drew a line down the center and reflected it, it's going to look exactly the same. That's going to look at the same. I can reflect it on the A, down this line here. I can't reflect it anything around here because then it would look different. The H can be reflected this way and this way. The X can be reflected this way and this way. U can only be reflected this way. If I do it this way, then it's an upside down U. Okay. You may want to hit pause and replay to watch that if you need to. Okay, next. quadrilateral ABCD is a kite. Whenever you have a kite, that means you've got two sides that are the same and two other sides that are the same, but these blue double marked ones have a different length than the red single marked ones. So we need to draw the line of symmetry. The line of symmetry is right here. So if I flipped this over to here, it's going to be the same. Okay, so explain why AC and BD are perpendicular. So we know they're perpendicular because this is your line of reflection, and therefore B is reflected over to D if this is a line of reflection. And if B lands up right on D, then that means the definition of a perpendicular bisector is if I do a reflection on a line of symmetry and it lands at the same spot as another point, then that means it's perpendicular. Okay, based on the line of symmetry, explain why angle ABC and ADC have the same measurement. So this angle ABC and ADC are the same, those little orange angles here. Since the lines of symmetry have the same shape on both sides, then angle ABC are going to be reflections of each other. And lastly, you've got a square, ABCS, that is inscribed in the circle. What is the smallest angle of rotation to have image A go on to image B? So how much do I have to rotate to get this dot to be up there? Well, if I twirl it, how far did I twirl it? I twirled it 90 degrees. Okay, that is the notes. Hit pause and replay if you need to.